Anyway, for today's science lesson, we're going to keep it real short. I have no idea kind of where Martin was in science or what you've gone over. So I'm just going to kind of go over what I used to do, because I used to teach science before Martin came to the Next Generation Zone. So I'm going to go back to the very beginning and talk a little bit about scientific method. And hopefully I remember enough to not embarrass myself. But let me share my screen, and we'll kind of talk about some stuff and then do a couple practice questions, and then we'll just kind of stop. I would imagine it'll be 15 to 20 minutes, maybe 30 minutes. And I'm going to try to keep all the classes short. So without further ado, let me share my screen and we'll get science class underway. Okay. So let me. All right. Caleb, until my confidence is ready, I'm going to check with you. Everything look good? Can see it?
I can see your PowerPoint that says science.
Perfect. Yep. And we're online. All right. Thank you, sir. All right. So dusting off the cobwebs of this old science PowerPoint. But anyway, just the kind of the breakdown of the science GED. 20% of the test is made up of earth and space science, so geology and astronomy. But the biggest chunk of the test is going to be life science, so biology, chemistry, biology, and then the physical science is the other 40%, and that will be chemistry and some but just like with social studies, which is the other class I teach, I try to emphasize to people, science test is much more about being able to answer questions and being a competent reader than it is being an expert in science. So lots of times people think they're terrible in science and they avoid the GED test because they're scared of it. But, actually, statistically, the science test is the one people pass the easiest. So it's not as daunting as you might think. So today, like I had mentioned, I just want to talk about the scientific method and kind of go from there. Again, like I mentioned in my morning class, we're kind of getting used to this remote teaching, obviously, and especially without video and audio, it kind of feels like I'm talking to myself. So if I'm talking too much or I'm too boring or talking too fast, I apologize. Hopefully things will improve. But again, just kind of getting some stuff out there so you guys can have something to do. So that's what I was looking for. So the scientific method, and again, this were a normal core class where we were all together, I'd kind of be discussing this a little bit more. But essentially, the scientific method is how you answer a question scientifically, right? Because if you are, imagine yourself as a scientist, you have a question posed to you, you aren't going to just immediately come up with an answer definitively and say that is true without some kind of experimental knowledge or something to back it up, right? And so the scientific method is just basically this series of steps that you go through to answer a question soundly, right? So, man, this is like a blast from the past. I haven't done this lesson in a long time. But if we just come up with a hypothetical question, and I will try to go through this quick, but let's just say we want to know why. Let's just say our question is, how do we get GED testers to pass the test more? Okay, let's just make up a hypothetical question. None of this is accurate. I'm making all of this up. So if any of this is totally false, it's because I'm totally making it up. But let's say we as a group want to come up with a way to improve GED testing. We want to know, how can we make our students pass the test easier, more often, whatever. Okay, so that's our question, okay, right at the top. Right? I don't know if you can see my little cursor, but ask a question. So our question is, how do we improve GED test scores for our students. The first step, before we do anything, is we do background research, right? Look into seeing what's already been done, what's already been studied, right? Get on the internet, look for information. So the first step is we don't do anything other than we go out and we look to see what's already been done, or what kind of information we can find that gives us a little bit more, sheds a little more light on our question, okay? Then once we've done that, then we construct a hypothesis. So some of you have probably heard of a hypothesis or kind of vaguely know what one is. I mean, most simply, I remember being taught that a hypothesis is an educated guess, right? In other words, it's what we think the answer to the question might be. And the reason it's an educated guess, and not just a guess, is because we've done background research. Right? Because we've done some amount of background research, there is something to support our guess, right? Or our hypothesis, right? So we don't just come out of left field and say, you know, I think GED testers are going to do better if they eat more candy, right? If I don't have any background research to back that up, then it's just a guess. It's not an educated, not a hypothesis. And also, you'll see or you'll hear hypotheses mentioned as an if, then, because statement, right? In other words, if this thing is true, then such and such will happen because of these reasons, right? And again, this is all, it would be easier if I could be writing up on the board, but just kind of bear with me and I'll try to get through this, right? So let's say we've done our background research and for whatever reason, we find, you know, we look at a bunch of GED test scores and we see that GED test scores seem to be higher in the morning, right? And again, bear with me, this is made up. But let's say we think our hypothesis is going to be if GED testers test in the morning, then we think they're going to be more successful because on the book, right? Who knows? Maybe it's because they've just eaten breakfast or done this or that, right? So glad to see Kimmy's back. Thought I had sent her back. But yeah, so anyway, let's say for the sake of experiment, our hypothesis is if students test in the morning, then we think they're going to be more successful because they're more focused, okay? So then the next step is we set up an experiment. And I'm not gonna, and this is definitely the portion of the class that I'm gonna kind of speed through because it's not very fun to sit here and set up an experiment without, you know, being together and kind of collaborating. So imagine an experiment we could set up that would test that theory, whether or not people actually GED test better in the morning than the afternoon. We could set up an experiment where, say we have 10 people test in the morning, 10 people test in the afternoon, and we look at their scores. Okay? So that's a very rudimentary or rough test. But let's say that's our idea. We're going to have 10 people test in the morning, 10 people test in the afternoon. We're going to look at the scores and compare. So the next step is the procedure working? In other words, did the test run how we wanted it to? Well, if yes, then we go down and we look at the data and we draw conclusions. If no, then we have to go back and we got to do it again, right? We have to troubleshoot and carefully check all the steps, reset it up. So think about that experiment. If we have 10 people test in the morning and 10 test in the afternoon, there's going to be some problems with that. And what are some potential problems? Well, what tests are they taking? Are they all taking different tests? Are they all taking the same tests? What about the testers, right? Are the 10 people that test in the morning, maybe they're just better testers than the people in the afternoon. There's lots of variables, things that we haven't thought of that might affect the outcome of the test, right? So these are all things that factor into the scientific method, right? So maybe we come up with a way to improve the experiment, to make it more accurate, right? So one thing we could do, we could increase the sample size or the amount of people testing. Because if we have 100 people testing in the morning and 100 testing in the afternoon, that information is going to be more reliable than just having 10 people testing in the morning. You see where I'm getting with this? I'm not going to go through round and round and round, but as a scientist, you would essentially keep trying to improve that experiment so that you are removing the most unknown variables possible and getting the most accurate data possible. Right? So bottom line, we fix our experiment, we have it running right. Now let's say, yes, the procedure is working correctly. The next step is we look at the information and we draw conclusions, right? So when we do that, one or two things will happen. Either the results align with our hypothesis, in other words, confirm what we thought, or they don't, and we have to kind of go back and rethink our hypothesis. And we do the whole thing over again, right? And it's only when we come up with an experiment that runs properly, that gives us data that aligns with our hypothesis, do we finally communicate our results or say we have an answer. So that whole process is kind of considered the scientific method. So a couple things, and then let's see, how are we doing for time? 1:20. All right, so let me go through just this. Let me see. Actually, for the sake of time, I'm going to skip this example and go to this example. Okay, because I want to talk about it some terms, and then if we have time, I want to look at a practice question. So in this example, John is a manager for a paper company. He thinks he has a special juice that will increase the productivity of workers. He creates two groups of 50 workers each and assigns them the same task. So in this case, they're supposed to be stapling sets of papers. Group A is given the special juice to drink while they work. Group B is not given the special juice. After an hour, John counts how many stacks of paper each group is. In the end, Group A made 1,587 stacks, and Group B made 2,113 stacks. Okay, so John is the manager of a paper company, and he thinks if he gives his workers this juice, they will be more productive. He sets up an experiment where one group is given the juice, one group isn't, and then he looks at how many stacks of paper they stapled at the end of the experiment. Okay? So a couple things. The first thing is, over here on the left, control group. So what is a control group? So anytime you have an experiment, you have to have at least two different groups, right? So if we're testing the juice, we have the test group, or the group that's given the juice. But then, even though group B isn't actively being tested, we have to have a group that isn't given the juice, so we have something to compare it with, right? If we just gave everyone the juice and they stapled a bunch of papers and we said, yeah, look how many stacks of paper they stapled because of this juice. You don't have anything to compare it against, right? So the control group is the group that is not actively being tested. It's just there to help compare it to the test group. Okay? Does that make sense? And again, I have my chat hidden, but just as a reminder, if you have questions, and like I said, bear with me. Where is it? Good. I see people are signing in, so I just wanted to, again, reiterate, if you have questions, use the chat because the video and audio stuff is disabled, and make sure you type your first and last name in the chat so we know who's here. Great, I appreciate you guys doing that. Back to this experiment, right? The next thing is talking about independent and dependent variables. So this is a little bit confusing sometimes, but when we talk about variables, we're talking about things that can be changed, right? So the dependent variable is the responding variable, or what is actually being tested. So in this example, right, the variable that's being tested is worker productivity, right? In other words, this person wants to make his workers more productive, and so the dependent variable, or the reason the test is being run, is to see, is productivity being increased or not? That's the dependent variable, right? The reason we call it dependent is because it's dependent on the question, right? Because you can't change the dependent variable without changing the whole question or the whole experiment. The independent variable or the manipulated variable is the one that can be changed, right? In other words, it's the thing we think is impacting the dependent, right? So think about that for a minute. If the dependent variable is worker productivity, what do you think the independent? What do we think, or what does John, the manager, what does he think is impacting productivity? And ultimately, what he thinks is impacting productivity is the juice, right? So the juice in this situation would be the independent variable. And again, it's independent because if we determine the juice isn't working, then we can just come up with a new independent variable. Maybe we think something else is going to increase productivity. Right? We can change it without changing the framework of the question. Okay? So just going over the last couple questions. Let's see, 133. All right, I'm doing okay on time. Question number 4 over there on the left-hand column. What should, I don't know why it says Smithers. I think I switched John. Just pretend it says John. Okay, so what should John's conclusion be? Was the juice successful in increasing productivity? Well, based on this experiment, no, because group A was given the juice, group B wasn't given the juice, and group B ended up making or stapling more sets of paper, right? So his conclusion would be that the juice wasn't productive or didn't help increase productivity. But number 5 says, how could this experiment be improved? Well, just like we talked about in the last example, right? There's a lot of shortcomings to his experiment. It might be that the juice is beneficial, but maybe the sample size is too small. Maybe we need to make more people, right? Or test more people. Maybe we need to test it over a longer period of time. Maybe we need to give the juice to group A before working instead of while they're working. Right? Maybe the fact that they were stopping to drink juice was impacting their productivity. Whereas maybe if we give them the juice beforehand, maybe then it does impact productivity. So you see, again, I don't want to literally talking to myself about this, but I don't want to talk about it for too long, right? How could this experiment be improved? There's endless ways that this experiment could be improved, right? So just be thinking about that. When we're talking about science or the scientific method, think about how you can improve your experiments. And it's been a while since I've taught science, but I do remember that, and I think it's still the case, that on the GED test, one of the short answer or the essay form questions is about setting up your own experiment. So be thinking about these kind of things because you're likely to see something like this on the test. Okay, so let's see. We have just enough time, so I want to pull up these questions. And if you're looking at these on a computer, hopefully this is zoomed in enough. If you aren't, I apologize, and it won't be very helpful if you're like trying to squint and look at this on a phone. But let's, for the sake of time, let's just look at number 4 here, and we're just going to do number 4. Okay. So if you have a computer and you can read this, great. If you can't, I will read it to you, and we'll just kind of do the best we can. Again, I apologize for none of this really being ideal. In a perfect world, we would all be together in a classroom going over this and asking questions, but just doing the best we can, so bear with us. And like I told my social studies class earlier today, and I won't harp on this every day, but since this is the first day of classes, I just want to say and emphasize that if you need help, or if you're feeling like this isn't working or not, you're not getting what you need out of this, ask us. Email us, contact us through the website, give us feedback on what we can do more to help you as students, because that's really the only reason we're doing all of this, is to try to stay connected enough to help you guys move forward in your GED. So again, I know none of this is ideal, but just ask us or tell us, if there's things that you need that we're not providing. We want to make sure we get that feedback. So make sure we know, and then you reach out. All right, enough of that. So number 4, this is, surprise, surprise, talking about the scientific method. Okay, so suppose you notice your right knee hurts every time you play softball. You suspect that one of the movements involved in playing softball is causing your knee to hurt. You're not sure which movement is the culprit. So you decide to do a scientific investigation to find out more. Okay? So then it says match each of the following steps of the scientific method with a phase of your investigation. Okay, so the steps are: form your hypothesis, test your hypothesis, collect data to test from your hypothesis, and D, form a conclusion based on the data from your test. Okay, so we've got these 4 things down here, right? Because we're on slideshow, I'm not sure you can actually see my cursor, but I'm just going to do it. So number 1 says, make a list of each of the movements involved in softball. In the off season, when you are not playing entire games, you plan to perform each movement several times without performing the others. Okay, so that is what one of those 4 things. A, form a hypothesis. B, design a test for your hypothesis. C, collect data to test your hypothesis. Or D, form a conclusion based on the data from your test. And actually, let's maybe go through this a different way. Let's look at these 4 things and see which one sounds like a hypothesis. Let's just work from top to bottom, A to D. So remember, a hypothesis comes first, while it comes after background research. But we're looking for which of those 4 things sounds like an educated guess. So I've already read number 1. I'll read number 2. Based on the data you collected in your experiment, you think it is likely that stopping suddenly after running a short distance is indeed the cause of your knee. Okay? Number 3, based on your experience, you make a guess about which of the movements involved in playing softball puts the greatest stress on the knee. You suspect that it may be stopping suddenly after running a short distance. And then lastly, number 4, after performing each movement in isolation, record how your knee feels. Let your knee recover between tests of each type of movement. Okay. So, form a hypothesis. Again, this is a hard conversation to have when we don't have back and forth dialogue, right? But if I look through these, the one that sounds most like an educated guess or a hypothesis is number 3, right? Based on your experience. Background research can be anything. In this situation, it could be your experience playing softball. So based on your experience, you make a guess, right? That's the key word. Remember, look for things that make this easier than maybe it seems like it is, right? That's a red flag right there. The fact that it uses the word guess tells me probably going to be the hypothesis. Based on your experience, you make a guess about which of the movements involved in playing softball puts the greatest stress on your knees. You suspect that it may be stopping suddenly after running a short distance. There's our hypothesis. So, B, design a test for your hypothesis. Which one of these looks like a test? Or, right, if you were to run a test, which one of these 4 would match up with that? And again, I wish I could talk to you about it, but number 1 to me looks like the best answer in terms of which of those 4 is a test. You make a list of each of the movements involved in softball. In the off season, when you are not playing an entire game, you plan to perform each movement several times without performing the other. You're going to do all of these different movements in isolation from one another. See which one aggravates your knee. That's the test. So B is number 2. Okay. C, collect data to test your hypothesis. Okay. Collecting data, me, sounds like number 4. After performing each movement in isolation, so after performing the test, essentially, record how your knee feels. Let your knee recover between tests of each type of movement. Right? So that's the data we're collecting. And then lastly, D, form a conclusion based on the data from your test, our conclusion is number 2, right? Based on the data you collected in your experiment, you think it is likely that stopping suddenly after running a short distance is indeed the cause of your knee pain. You confirmed your hypothesis. So, again, I know that was a lot of talking, and I apologize if I'm boring, and I know Martin's science class is way more fun. And like I had mentioned earlier to Kimmy, Martin will be back doing science at some point. I'm just kind of helping him until he gets his feet underneath him with the online stuff, and until we have a second math class. Because as of now, instead of having a second math class, we're just having one class of every subject. So the schedule will look a little bit differently down the road. For now, for the foreseeable future, this is kind of our set schedule. We'll have math at 10:15 with Sean, social studies with me at 11:15. Martin will do reading at 12:15, and I will do science at 12:15. And I realize I think I jumped right into this without introducing myself. I'm Mike, for those of you that haven't met me. And I typically teach social studies and math, but for the foreseeable future, I'll be doing social studies and science. So that's it from me. We'll be back tomorrow. So every day, Monday to Thursday, the classes will be the same. And we, again, will do the best we can. If you need anything, contact us at the website. Ask us questions. Be proactive. Get out there and make sure we're helping you achieve your goal of getting your GED passed. And if we're not doing that, then let us know. So that's it for me. I will see everyone tomorrow morning for social studies. And until then, have a nice day and stay safe out there.